Okay, welcome back to class. Now look at this example. Now we're given a linear transformation mapped from R3 to R3. Okay, so and it was defined by this equation. So look at your map definition. As you can see, R3 to R3. So your vector spaces here are the three-dimensional coordinate system, and we have to determine the range of T and the rank of T. If you have found your range, obviously you have found your rank, because rank, like we discussed is in the previous video, is the dimension of your range, right? So to find your range, you recall, what did we say range is, right? We said the range of T based on this question given to us would be you are looking for or let me just define the general one first. We said that W, which must be an element of capital W, such that your W equals to T of V, right? For any V which is an element of R. Okay, so we defined our range as this. Now if you compare the definition of this range to what you have in the question, so the first thing first is you want to let your W to be equals to ABC. This is the first step to take. After you have done that, then your range now becomes, your range of T now becomes that ABC that you want to find, right? And it must be an element of this time around you won't have W, right? What's your W in this question? Your codomain is R cube. So you say ABC, which is an element of R cube, such that ABC, right, equals to T of V. In this question, your V, which is your domain, is what? X comma Y comma Z. I believe you understand that, right? So this is your V. This guy here is your V. So, and then you close your brackets. Okay. Now this is what we want to solve. But don't forget that this ABC equals to T of X comma Y comma Z already implies that our ABC itself is actually equals to the equation given to us. I mean this coordinate system you have here. So it means that your ABC is equals to X minus Y plus Z, which is 2X plus Y minus Z, and then minus X minus 2Y plus 2Z. Now if this is true, it simply implies that our range of T is then equals to the set of these guys, as you can see, X minus Y plus Z, comma 2X plus Y minus Z, then minus X minus 2Y plus 2Z, and all these guys are obviously elements of R3. So this is your range. But we are not done. Now to finish up this range, the next step is to write this particular set in as a linear combination, right? So this implies that you have X into, now the reason why I'm writing it as a linear combination is so that we can form a matrix out of it and then derive, you use row echelon form to derive your bases. So once you have gotten your bases, your range will actually be the set of your bases. Alright, so that's what we are trying to do. Now your X of, let's use linear combination. So this is how we do it. The first thing, we have X, Y, Z. So you have X into bracket. You can see 1 here, right? 1 as in the coefficient of X here. You move to the next coordinate, you have 2 with X here. You move the next coordinate, you have minus 1. Okay, so that's where we write the linear combination plus Y into the first one you have minus 1, the second one you have 1, and the third one you have minus 2 plus Z, okay, into the first one you have 1, the second one you have minus 1, and the third you have 2. So this is this particular set has been written as a linear combination. Now you form a matrix from this. That matrix will be 1, 2, minus 1, minus 1, 1, minus 2, and 1, minus 1, 2. Now that you have done this, the next thing is you want to reduce this to row echelon form. Okay, you reduce this to row echelon form. So how do we go about that? You can, you reduce this to row echelon form. What we want to do is you want to first, your first pivot here is 1. So you want to reduce all the elements beneath it to 0. So what do? You form new R2. You can just add the second row to the first row. Then to reduce this guy to 0, on the third row you can just subtract the third row, right? You can have R3 minus we can even add r3 plus r2. What are we adding? Look at 1 plus minus 1 is just 0. That does the trick for us. So our new matrix will now be 1 2 minus 1, right? Then you have here 0, you have here 0. Then in this place you have r2 plus r1. r2 is 1. Okay, so plus r1 plus 2, that's 3. Then you have here minus 2 plus minus 1, you have minus 3. Then in this place minus 1 plus 1, you have 0. 2 plus minus 2, you have 0. Alright, so we have been able to reduce the row echelon form, but you can also decide to divide this by 3, okay? So that you won't be having r2 divided by 3, r2 divided by 3. Okay, it's good to reduce it to the simplest form since we are looking for the basis, divided by 3. So then you have let me signify that we are forming a new r2, which is r2 divided by 3. So if you do that, what you have 1 2 negative 1, and you have 0 1 minus 1, you have 0 0 0. So from here, this implies that our range, so anytime they give you range, this is how you go about it. So your range now is actually equals to the span, okay, of your bases. So you have 1 2 minus 1 and 0 1 minus 1. Okay, so this is your range. Alright, so one is saying 1 0 0 0 0 0 0 be there. It can't be there. It can't be there because your range has to be linearly independent vectors, okay? And your span, your basis rather, has to be linearly independent vectors, and this guy do not satisfy, okay? So from here, what next we have to find, since we have found our range, okay, I think we have to find our rank, and your rank is simply equals to rank r of t, simply equals to the dimension of the range. And I said the dimension of your range is simply the number of elements in your range, right? So if you look at your range, what you are spanning, you have 1 and 2, so your rank is simply 2 because we have 2 elements in this set of your range. All right, let's look at one more question so we can conclude on range of a linear map. Look at this second example before I give you your exercises, which should be submitted individually. Look at this second example. So we have to find range t. We have to find range t, okay, if the linear map, okay, t such that r cube is mapped to r squared, okay, and is defined by t of x, y, z, and this is equal to minus x plus y and y minus z. Okay, so we asked to find the range, and also they asked us to find the rank. What is rank r of t? What is rank r of t? Sorry, what is the rank? Okay, what is the rank r of t of the linear map t? So how do we go about the solution? Just the way we explained the former example. The first thing first you want to do is define your range. Don't forget the range of your linear map t is actually equals to, now let's not generalize because of time, let's just move straight to the point. Now your range in this question, you first thing, like I said, first thing first, you let w to be equals to what? Now if you look at where we are coming from, we are going from r3 to r2, right? And I said that your range is a subspace of your codomain, meaning that in this case you won't have a comma b comma c, but just a comma b. Why is that? Because your w must be an element of your capital W, where your capital W in this question is actually r2. I believe you understand. That's why we have w to be a comma b. You look at your codomain when you are looking for your range, not your domain. Okay, so now you have from here that your a comma b to be an element of r2 such that a comma b equals to t T of what? You look at your domain. Your domain is x comma y comma z. Okay. All right. Yeah. So where of course your x comma y comma z is an element of R cubed. So this is your range, your definition of your range. Now the next thing you want to do is you write that your range is actually equals to a comma b, which is an element of R squared, such that a comma b equals to, now you ask yourself, what is this? What is t of x comma y comma z? Is given in the question here. So that will be minus x plus y comma y minus z. Okay, so you have this guy, and this implies that your a comma b, as you can see obviously, is minus x plus y and y minus z, right? So it implies that our range t is actually equals to minus x plus y comma y minus z. Okay, so this is our range, of course, which is an element of R2. Okay, so this is our range. But like we said, once you have gotten to this point, the next thing you want to do is you want to write what is given to you as a linear combination, right? So you want to write it as a linear combination. So that implies that you have x to be into what? Minus 1 comma, is there x here? There's no x in the next one, so that's 0, plus y. Look at the first one, is there y? How many? What's the coefficient of y? You have 1 comma, look at the second one, is there y? Yes, comma 1, plus z. The first one, is there y? No, so that's 0. Is there y in the second one? Yes, the coefficient is -1. So this is the range in linear combination. So you form a matrix from that: minus 1 0 1 1, then 0 minus 1. I believe you know the drill by now. So you use row echelon form to reduce this guy, so that we can eliminate any form of linearly dependent sets, right? So how do we do that? From what we have here, to reduce this to row echelon form, right? I believe looking at this question, it looks like it's already in row echelon form, but I mean, you might want to maybe swap the row. You might want to swap form a new row 2 by swapping it with row 1, right? So maybe you can have 1 1 minus 1 0 0 minus 1, however way you write it. Now if you look at this, there's no way you want to reduce this. It is already reduced in its row echelon form. If you add this up, this will be 0. If you add this up, this will be 1. If you subtract, you will still not get at any point in time what you're looking for. So the best bet is you leave your answer like this. If you add these two up, you have minus 1 and 0, right? You have minus 1. If you form a new R3, let's just satisfy our conscience. If you form a new R3 by having R3 plus R2, what would you have? You have okay, the point is the point is you want to eliminate the point is that you want to eliminate all the entries that are below the first pivot, right? And the first pivot is 1. So if you want to eliminate all the entries below that guy, which is minus 1, if you want to eliminate this minus 1, what do? Just add it to this, right? And if you add it to this, it will make this guy 1. So you can see that there's nothing you can do any further to this. So that leaves us with our range being actually equals to the span, okay, the span of 1 comma 1 minus 1 comma 0 and 0 comma minus 1. So as you can see here, your rank, which is the dimension, the rank of t, which is the dimension of your range of t, will just be equals to 3. So this is the rank of this particular linear map. I believe we have answered all the questions. So try this question yourself. You might need to pause the video so you can write the exercise in your notes and the exercises in your notes. And please don't forget to submit individually. Alright, bye for now.